Trigonometry. This is a very important branch of math, and this deals with the study of right triangles and the ratios that work within right triangles. It's a branch of math that's used in so many different careers, everything in science, engineering, aviation, surveying, all kinds of things are using sort of this math here that we're teaching. So there's three main ratios that we deal with in trigonometry. These are called sine, cosine, and the last one is tangent. And there's some others too, but these are kind of the three big ones. These, you can solve most triangles with these three. So let's talk about these. With a right triangle, I always start off with a reference angle. It's kind of whatever angle that I have information for that I'm trying to use in my right triangle. It can't be the right angle, and I'll show you why. So here I'm going to use this 47 degrees. This will be my reference angle. And the first thing I need to do is label my sides. That way we're both talking about the same sides and there's no confusion here. So the side that is directly across from the reference angle that this is pointing to, I'm going to call that the opposite side, and I'll put an O for opposite. Your longest side, or if you can't tell what's the longest, look at what your square is pointing at. Right? This was always your longest side. This is called the hypotenuse, and I'll put H for hypotenuse. And then your third side, the one that you have left, is called adjacent. We put A for adjacent. Adjacent just means next to, so this is the side that's next to the reference angle, but just know that it's your third side. So naming these three sides, this allows me to use trigonometry ratios on all of these. So my first one was sine, and your calculator just abbreviates it as SIN. This ratio is opposite over hypotenuse. If I divide these two sides, that gives me sine. The next one is cosine, and your calculator abbreviates that as COS for cosine. This is adjacent over hypotenuse. And our third one is tangent, which your calculator just says tan, T-A-N, for tangent. And this is opposite over adjacent. So with these three ratios, we can solve for a lot of missing pieces in right triangles, sides, angles, whatever we need. I have an example here. So here I have a right triangle, and they're saying, what is x? Can you solve for this side? If I make 67 degrees my reference angle, that would make this side here, side AB, the opposite side, whatever's across from that. And that means that x is the hypotenuse, and what I have left over, side BC, is my adjacent side. All right, and let's just talk really quick. The reason that I can't make 90 degrees my reference angle is because if I make this the reference angle, then this is the opposite side and the hypotenuse. It would be both, which would not work. I can't solve this then. So what I'm thinking of next is which trig ratio should I use here? I have sine, cosine, or tangent. I have these three. And what I'm trying to find is the hypotenuse. What I have is the opposite side. Opposite side is 12. Hypotenuse is x. And then adjacent, I don't really need for this problem, so I don't even really need to look at that. So I'm thinking which trig ratio talks about opposite and hypotenuse? Which one kind of gives me the relationship between these two? And it's sine. Sine is the one that I need to use for this problem. So here's the way I set this up. I'm going to write sine of my reference angle is equal to opposite over hypotenuse. So here that's 12 over x. And from here, I need either a trig table or I need my calculator, my scientific calculator, because I need to figure out what is sine of 67. Right? So if I type 67 into my calculator, I press the sine button, this gives me 0.9205. And I always want to use 4 digits here just to make myself more precise. I put 0.9205, use 4 digits, and I'll just bring down the rest of this. I'll bring down the 12 over x. And I'm almost done here. I just need to solve for x. The easiest way to do this is to cross multiply. If I put this number over 1, right, because I could divide any number by 1, it doesn't change the number. If I put this over 1, then I can cross multiply this, right? 1 times 12 is 12. And then this is going to be 0.9205x. Okay, and my last step here is to divide this. I'm going to divide both sides by 0.9205 to get rid of that. There we go. So if I divide 12 divided by 0.9205, it gives me about 13.04. You might get something a little bit different just depending on how you round or how your calculator rounds, how it stores digits, but this is going to be my answer. And you notice here I started off with 4 digits to keep this more precise, and here I definitely want to go to 2 decimal places just to have a more accurate answer. So this could be my answer. Let's talk about one other thing. So here's kind of another example. This one looks a little bit different, and you might right away notice that this is a symbol that you haven't seen before, this right here. So this is not a 0. This is called theta. It's a Greek letter theta. But we really just treat this like an x. It's just kind of a different way of writing an x that's used in trigonometry for reference angles. So again, this is called a theta. Everything else, though, is really pretty much the same. If I look across from what this angle is pointing at, this is my opposite side. My longest side is still hypotenuse, and what I have left over is adjacent, the 16 centimeters. So here I have opposite, I have adjacent. I'm not really using hypotenuse. There's no information here for that, but I'm trying to figure out what is this angle. So thinking back to our three ratios, here you might notice that I want to use tangent. Tangent's the one that talks about opposite and adjacent. So this is the only one that I can use for this problem. I'll set this up just like before. Tangent of theta is equal to opposite over adjacent. So here opposite is 34 and adjacent is 16. I'm going to go ahead and divide these. So on my calculator, I'm just dividing 34 divided by 16. I'll bring the rest of this down. So 34 divided by 16, that gives me 2.13, and I'm almost done here. I have tangent of theta is equal to 2.13. So what I really need to do to finish up this problem is to get rid of the tangent. I need to get the variable here, the theta, by itself. So how can you get rid of tangent? If you look at your calculator, you might notice that you have a inverse tangent button. It looks kind of like this. So this is the button I need to use. I need to type in 2.13 and figure out what's the inverse tangent so I can cancel that out. Right, so your last step here, if you do this all correctly, you should end up with 64.8 degrees. So you're kind of working backwards. Here we gave you 2 sides, and you're kind of working backwards to figure out what was the reference angle. This is the basics of trigonometry.